Hey folks, Thomas here. Welcome back to Mears Lab. A little while ago I made some videos about wooden circuit boards, and here's why. This is a stereo vacuum tube amplifier, so it has two fully independent channels, and these are the inputs right here, left and right. And there's a 12AX7 and an EL84 tube per channel, and each one of those has a Hammond 1750B output transformer. And so there's two identical channels right there, and they have a shared volume control right here. The knobs have a really nice amount of resistance when you turn them. They're all double pots, and the knobs are made out of metal, so they feel really nice. This is basically two Fender Champ 5F1s wired in stereo with a traditional Fender tone stack in here as well too. And then we've just got a single power switch right here, and there's no tube rectifier in this. I decided to go with a full bridge solid state rectifier. And let's flip it around here and have a look at the back. Okay, so there's our 3-prong power inlet right here, and the power transformer for this is another Hammond transformer. It's a 270FX. It's got lots and lots of current for the B+, and way more than is even needed for this amplifier, but I wanted to use a really nice heavy-duty power transformer. Okay, and here's the fuse for it right here, and here's a ground lift switch right here, so you can flip this and it'll get rid of any sort of weird ground loop noise that might be happening in your system if you hook it up and there's some sort of a weird power supply somewhere in there. This can get rid of that ground loop noise right here. And here are the two outputs. There's one for the left channel and one for the right channel. The cabinet's made out of solid birch, and it has a satin poly finish. So there's not that much to it. It's just a simple amplifier, but that's all it's meant to be. Just a basic stereo tube amplifier. Alright, let's have a listen to what the amp sounds like now. And here's the setup for the audio recording. Up on top here, we can see the stereo tube amplifier. And below it is an old Art Multiverb LTX. It's like an old crusty effects processor, and it does delay, chorus, and reverb. And it's not the greatest sounding, and it's not even in the greatest of condition, but it works okay, and it'll work just perfect for giving us a stereo signal for the guitar and for adding some effects to it so that we can hear the guitar in all of its stereo glory. Here's the speaker cabinet that we're going to use for the main left channel. It's one that I made here, and this is a ported cab, and inside of it is a 12-inch Celestion speaker, and it is mic'd up with a Lewitt 440 condenser microphone. Okay, over here, that is, it was an accordion amplifier made by Quartervox, and right now it's just a 212 cabinet. It's mic'd up with an SM57, and I'm just using one of the speakers, just the one on the right side. And both microphones are mic'd up at about the same position of each cabinet, and I've dialed them in so that they are in kind of their own sweet spots, and the capsules are phase aligned as well too, so there won't be any weird phase audio issues. Up here on the desk I have a tube preamp I made a while ago, and I'm plugging my guitar into this first, and then out of this into the effects processor, and then out of the effects processor into the amp. That'll be the signal chain. I'm mostly using this so that I have a volume control for the guitar as the signal goes into the effects processor so that it doesn't clip it. Other than that, it doesn't really do too much to the guitar signal. It's pretty transparent sounding. Here's one of the guitars I'm going to use for today's demo. It's a really cool one. It's a Strat that a luthier here on Prince Edward Island made. This is a Ginger guitar. The luthier made a rosewood neck for it, and it has just a regular old standard Strat body and standard Strat pickups, and then the luthier upgraded the hardware and a couple other things on the guitar, and it sounds and plays really great. You'll get to hear it here in a minute. And over here I've got my other main guitar. This is my Fender Meteora, and it's got some wide range humbucker pickups in it. I want to get an idea of what the amp sounds like with the guitar plugged directly into it, so I'll do that first. I'll get started with the Meteor guitar here with humbuckers, and I'm plugged into the left channel, so the sound is only going to come out of the left speaker, but I'll edit it in post so that you can hear it at both speakers. But you're only hearing the left channel right now. Then after that, I'll do the right channel. So let's go up about a quarter of the way on the volume. Instead of going with a traditional point-to-point or PCB design, I decided to mount the components on some custom-made solid copper standoffs, and those copper standoffs are mounted directly to the inside of the wooden cabinet. In this video, we'll discuss how this amplifier works and how I made it, and we'll also do an audio demonstration of what it sounds like. And I'd also like to spend some time talking about the features and benefits of building with wooden circuits. All truths be told, I've been pretty anxious about making this video because in my previous videos about wooden circuit boards, I've had pretty mixed reactions. Some people thought that it was an okay idea, and quite a few people thought that it was frankly a terrible idea. After I released those videos, I wasn't really sure how I felt about this idea anymore, so I decided to just shelve it and then move on to some other projects. What really gave me cause for concern was the results of the moisture tests that I did on the miniature wooden circuit boards. The initial results from the moisture tests that I did on those mini wood circuit boards were not very promising. But here's the thing, I haven't released this information until now, but off camera, about a week after I did that test, I went back and tested the mini wood circuit boards again. In the meantime, they'd just been sitting undisturbed in the corner of my desk collecting dust. But after a week of sitting out just on the desk, some of the boards went back to their original condition, showing no connection at all whatsoever. And that gave me a bit of hope for it. It made me think, yeah, well, maybe this isn't so bad after all. Granted, not all of the boards worked out. Some of them still showed continuity after sitting out for a week, but some of the boards were just fine. Now, there's something I want to get clear here. I'm not saying that this is better than any other way of making an amplifier. I'm just saying that this is a way of making an amplifier, and that there's a lot of benefits to building an amplifier like this. Yes, there are some drawbacks, but then again, all designs have some drawbacks. Here is a look at the inside of the amplifier, and this is how it's all laid out. So the power transformer is back here, and there's the two output transformers right there and there. So this is the power supply right here, and there's the power supply filter caps. That's our power switch. This is where the EQ is right here. There's our three pots. There's the treble, bass, and volume right there. And here's the two EL84s. That's where the two 12AX7s are. And there's our two inputs. That would be the left channel, and this is the right channel right here. And with the outputs right here in the back, right? The same positions. That's the left and that's the right channel right there. One of the reasons why I like building like this is I feel like it's really simple. There's less parts and there's lots of room for the parts inside of the amplifier. There's not as many different types of build processes because you're basically just repeating the same process over and over again. Once you make and install one of these, install their components to it, every other one is basically the same. All of the parts that you need for building the basic amplifier, like the copper and the wood, those are all really easily sourced and very affordable as well too. Now this amplifier is far from perfect. There's a lot of things that I would like to improve on, especially since I built this a few months ago. But that's also something that I like about it, is when you build like this, it's really, really easy to troubleshoot and easy to work on. I found that building like this makes it easy to implement any ideas that I might have later on down the road. The basic idea was I wanted to make something as simple as possible that worked, that I could continue to further develop and make better and better over time. Probably one of the best benefits of building like this is you can put anything anywhere you want inside of the amplifier. You're not constrained by having to put things on a turret board that's stuffed away in the corner, and then you have to run really long wires over to it, or terminal strips that you have to mount components to fill it up, and then you also have to run long wires. You don't have to do that when you build like this. You can put the resistors right beside the tube sockets. You can put your caps right beside there. There's no need to crowd anything together. Everything's got a lot of room to breathe, and there's a lot of benefits to that. Let's take a closer look at the copper posts here. You can see that there's lots of room on them for solder joints, and they have excellent thermal management as well too, because the copper posts act as little heat sinks for the components that are soldered to them, so they help to keep the components in the circuit cooler by using these posts. Because these posts are made out of solid copper, they're really easy to solder to. And after you make your solder connection, it's really easy to inspect it because you can see it from all angles. The copper standoffs also have a small amount of flex to them, and that helps to increase the mechanical stability of the circuit, because as the amp gets jostled around in regular everyday service, if these were really rigid, then it would transfer all of that movement directly into the components. It's almost as if they act like little shock absorbers, and that leads to less mechanical failure points. You can see that the components are mounted far away from the wooden surfaces, and they have lots of open air around them, and that helps to dissipate any heat that's generated within the circuit. And any heat that is generated within the circuit can vent out of these holes for the transformers, which are oversized. Let's take a look at this EL84 and see how it's all wired up. Notice that there's wires running to each of the pins on the tube socket, and I did that for a couple of reasons. One of them is if I ever needed to replace a tube socket, it's really easy. I can just unsolder these wires and replace the socket and then solder them back in. I don't like the idea of having to solder multiple times to a pin on a tube socket. I'd rather just solder to it once and have it done with, so that there's lower chances of damaging the tube socket. And this way, if I want to change components, I'm only heating up these standoffs here and not the tube socket itself. And all the wires are really short, and I've kept everything separated about as far apart as I can inside here. This is the grid right here, and this is the cathode. This is the plate, and there's the screen grid right there. And here's the wires for the heater right here. I'm kind of going backwards here, but you can see that the signal for the grid of the EL84 comes from the plate of this 12AX7 through this cap right here, and the grid of that channel comes from the volume, which goes through all the EQ circuit, and then it comes from the plate of this side of the tube right here, and then that goes up to the input up here. By building this way, I'm able to really optimize the component positioning, and you can see that here, how the grid resistor comes in over here far away from anything else, and here's the screen grid resistor right here, and there's the cathode over there, and everything is equally spaced here to minimize any coupling. Being able to optimize your component positioning, because you can install them anywhere you want with these standoffs, that helps to reduce any inductance or coupling that can happen, which would reduce the efficiency of the circuit. There's also less of a chance for ground loops, because you can't just ground everything to the chassis. You really have to think every ground connection through and make sure that you're resolving it to the right point in the circuit to keep the noise as low as possible. Another thing that I really like about these copper standoffs is that copper is highly conductive. I did some research, and in fact the only metal that is more conductive than copper is silver. Copper is actually more conductive than even gold. I make these copper standoffs out of 14-2, which is just your regular everyday home electrical wire. I've been asked a few times why I started building amps like this and why I continue to build amps like this, and here's why. I started building amps like this purely for financial reasons. I couldn't afford to buy the proper parts. I knew what I should be using, but I couldn't afford to put food in the cupboards, let alone buy expensive parts. But I did have a bunch of old parts and radios lying around, and a small shed out back with some wood and a table saw. The dream of building my own stereo tube amp is why I got into electronics in the first place. I learned electronics from my dad, and he built a stereo tube amp when he was only a teenager. And I always thought that was so amazing, because electronics did not come naturally to me. I struggled to understand even the most basic fundamentals of electricity. So building my own tube amp, to me, always felt like an elusive dream that was pretty much impossible to attain. It seemed so complicated and so expensive. It wasn't until much later in life that things started to begin to make sense for me. I started doing electronics repairs on the side for extra money, and I was beginning to feel more confident in my abilities, so I decided to give it a try. I looked at what I had to work with, and it wasn't a lot, and that's when I started to wonder if I could make an amplifier with a wooden circuit board. So I began to do some research, and I discovered that it could work, but I discovered some drawbacks like moisture and heat. Naturally, wood is a very, very good insulator, which makes it great for electronic circuits. However, if the moisture inside of the wood gets too high, then it can start to conduct electricity because of the moisture that's inside of the wood, and that's definitely not good. So that's one challenge. And the other one is pretty obvious, like wood is very, very flammable, and electronic circuits can get warm or even hot sometimes, especially tube circuits. So that's another challenge I knew I'd have to try to overcome. However, I felt that if I could mitigate those risks, maybe it could work. I didn't have a whole lot to lose, and if it worked, I had everything to gain. So I first experimented by building some prototype wooden circuit boards. The boards worked, I installed them in some amps, and the amps actually worked pretty well. But no matter what I did, the boards always felt too cramped to work on. Everything was always spaced too close together. That's when I began to wonder, why have a board at all? If a wooden circuit board worked, then technically a wooden amp should work too. Or at least that's how I looked at it. So I set about making a prototype. The first one I made was very crude, and it had very crappy transformers. It really didn't sound good, but it did work. I used it for a little while to see if it would keep working, and it did. So I decided to build another one, but try to make it look and sound better this time. So I made a cabinet out of pine and stained it a dark chocolate color, and I ordered nice brand new tubes for it and nice transformers as well too. And I used all brand new parts, and it turned out sounding and working really good. Over the years I've modified and tweaked it a bit, but it's still pretty close to the original, and I've been using it as my main amp since then, still to this day. Next I made another amp, and I wanted to try to optimize the circuit this time and make it sound as good as I possibly could. I had an old tube reel-to-reel, and I was curious to see what kind of an impact the output transformers would have on the sound. So I used the transformers from that reel-to-reel for this amp. I also used the power transformer from it too. I wasn't as concerned about making this amp look nice. I was mostly concentrated on making it sound as good as possible. It ended up working and sounding very, very good. The wiring layout was significantly cleaner and had a really full and punchy sound that I think was because of the output transformers. Around that time, I took a break and worked on some other projects for a long time, while also experimenting with more wooden circuit projects like a tube spring reverb and some more wooden circuit board ideas. Then after a while, my family moved into a new place, and I got a much bigger and nicer workspace for the lab. That's when I got the urge to build this amplifier and incorporate everything I had learned up until that point. I also wanted to make it look as nice as I possibly could this time. There's still quite a lot of things that I would like to do to improve on this amplifier, but overall I'm very, very happy with how it turned out. I've been asked a few times if my amps are for sale, and the answer is no, they're not for sale. Don't get me wrong, I would love to sell amps. I think it would be practically impossible to attain any kind of safety approval for an amp built this way. I might still try it someday down the road, but it's very expensive, and for me, it's not a priority right now. And because I can't get any kind of safety approval on the amps, I can't really legally sell these amplifiers. So I've decided to share my idea on YouTube instead, because the main thing is I was able to achieve my dream. And I learned a lot about building amplifiers this way. In fact, if I didn't start building amplifiers this way, I don't even know if I would still be building them today. I think that as long as precautions are taken, this is a totally viable way of building audio electronics. It's not perfect, And it's not better, it's just another way of building. If anybody out there is interested in building an amplifier like this, then I encourage it. I feel like there are some reasonable ways to mitigate the risks, and there's a lot of benefits to this type of design as well too. If you do build anything that's like this, then please let me know. I'd love to see what somebody else can do with an idea like this. Okay, one last thing. I'm not really sure what to call this construction method. Maybe wood and post, or copper and wood, or copper wood. I'm not really sure. And I was wondering if I could maybe get some suggestions in the comments for what to call this building method here. And if I do, I'll mention it in a future video, and that's what I'll call this build method from that point on. Well folks, that wraps up today's video. I hope you enjoyed it. If you did, then don't forget to hit the like button, and you can always subscribe to the Mears Lab channel for more videos just like this too. Thanks again, and I'll see you next time.